Let's talk about monitoring, load balancing, and scaling within AWS. What are the benefits of monitoring your systems? Well, I'm pretty sure everybody knows about this, but let's just touch on a couple of benefits of monitoring. You do monitoring because you want to be able to respond to operational issues in a proactive manner. If you come from operations team, you might be familiar with the idea that you sit there, check the systems and make sure everything is fine. You look at the logs and monitoring tools, so on and so forth. The main idea, you want to be able to catch anything bad that might be happening to your system before it starts to affect customers. Above all, you are going to monitor because you want to improve performance and reliability. You are the eyes and ears of your customers on your own system. Customers don't like broken systems. They will just walk away. There's way too many competing companies out there to sit with a broken system. So you sit with your systems, monitoring them so that you can improve its performance and make it much more reliable. Threats are something that are real out there, and you don't want to be caught by surprise with a system that is not patched accordingly. So monitoring allows you to understand if your security is at the level that you want within your organizations and your system. That's why you want to monitor and look at the alerts all the time. Anywhere within business, we make decisions, and it's better if those decisions are made using data or are data driven. You don't want to guess. You don't want to just thumbsuck and pick a direction. You want to look at data, and that data could come from metrics, could come from logs, traces, and many other places from within your applications. Most of the time, when we are monitoring and observing our applications, we tend to see opportunities of minimizing cost, maybe in places where we are underutilizing a very big EC2 instance. When we see such opportunities, we can then right size our infrastructure to cater for our workload, thereby saving cost on that particular infrastructure setup. Within AWS, we have a service that is called Amazon CloudWatch. So CloudWatch is a monitoring and observability web service that allows customer to be able to see real-time data that can be able to take actions on. It allows you to monitor your AWS resources, including the on-premises servers as well. For you to be able to push the data, you need to have a CloudWatch agent configured with permissions so that you can be able to push the metrics and the logs into this central place. Once you have this central place now, you are able to go on and visualize these metrics or logs or anything that might be of importance to you to be able to gain insights from your application to take better decisions after that. CloudWatch has abilities of creating alarms based on metrics. You can also, by the way, create alarms based on logs. How do you do that? You can create metric filters based on the logs. Metric filters are a way of filtering the log by searching for a particular word or phrase inside the log. If it finds that log, it technically converts the log into a metric. Once you have a metric, you will then be able to create an alarm that can be triggered in case, of course, there is that particular term in the logs. And there are many other responses that you can actually do once you get that trigger. Talking of metric, by the way, what exactly is a metric? A metric is a data point that represents the health and performance of your system that is measured over time. Within CloudWatch, we also have logs as well. So this allows you to capture these immutable events coming from your systems and even applications. You can also push logs from on-premises as well. These logs are going to be stored in a CloudWatch log group that you can create and specify what exactly that log group is, and then start to send all of the logs in there. This, remember, is a central place. If you have over 100 or 1,000 EC2 instances or VMs on premises, using this central location to store the logs and many of that observability related data is a good thing. In case there is a problem, you know exactly where to go to, and you know what to also look at as well, instead of data being all over the place, which also means this data must be secured all the time. I mentioned earlier on when I spoke about the logs that these are immutable. By immutable, we don't mean that they cannot be changed. We just say that they should never be changed. They should stay like that because the system generated those logs exactly as they are. So why should they be changed? The only people who change logs to cover their tracks are bad people. And of course, that is why you need to secure these logs, because they tell a story about what's happening within your applications and systems. Metrics can also be drawn within the dashboard. Dashboard is one of those best places if you want to have a real-time view or insights about what's happening with your application or infrastructure as a whole. Here's an example here of a CloudWatch dashboard that is showing the Amazon EC2 metrics for network out and CPU utilization. You get to see all of the data there. And this is for the Elastic Block Store metrics for volume idle time and volume write operations, so on and so forth. This data can then be added into the dashboard, and that dashboard could be playing in a big screen next to your team so that you have that real-time view of what is happening with your architecture or your applications. Let me see if I can just show you where some of these things are. CloudWatch, by the way, is one of those big observability tools that you'll ever need. It can look at metrics from many different applications, resources, and even on premises, including logs as well that you can push across into the central place here. The logs, I didn't tell you earlier on, they are stored forever, like permanently there. You may want to create some retention for your logs so that you delete the ones that are much older. Talking of logs, I have some couple of log groups here in my account in US West 2 regions that come from the applications I was running from this account. Depending on the retention, I get to see, of course, if the logs are still there. So this is my retention for each of these log groups. You can see all of these are written never expire, and just one of these is written 1 day. So I might need just to clean up a couple of those. Okay, let me just maybe pick one here. This is a log group. Within the log group, we have something called a log stream. So think of it this way. If you have a log group, let's say var log messages, how will you know which EC2 instance deposited logs there if you have var log messages? Well, the log streams will tell you about that, because each of these streams will represent an EC2 instance that was writing the logs. And if you go into that particular log stream, then you get to see the actual logs that were now written there. This is what you'll most likely be dealing with then when you are somebody who is looking after these systems in an operational manner, checking every day or so on and so forth. And of course, checking these logs every day may also be time consuming, which is why we have something called metric filters. A metric filter, which by the way, should just see if I can go back here. Okay, a metric filter you create on the log, it allows you to search for a particular term in the log, maybe 403 or 502 bad gateway, so on and so forth. Now, it's a way of converting a log into a metric. And once you have a metric, you can then go on and trigger many other events. Metrics are generated free of charge by AWS for the services that you use. The only catch is these metrics are 5-minute interval. So if you want anything that is lower than 5 minutes, maybe every 60 seconds, then you need to pay for those metrics. And we also generate standard metrics as well. So if you require other metrics, maybe related to memory, which we don't really collect, you need to create custom metrics for those and then push those metrics across, which of course you will pay for. But for these ones that are 5 minutes in terms of the interval and basic type of metrics, they are free of charge. They stay here until 15 months. These metrics are going to be stored for up to 15 months, but the logs are stored forever. Retention is never expire. Do remember the differentiation there. So these are the metrics that are available that you can go on and utilize. For example, if you go to EC2, you get to see metrics that are related to EC2. This is per instance because I don't have an auto scaling group here. And these are a couple of EC2 instances I ran. And this is CPU utilization. And you get to draw it on the graph here. But anyway, it looks like this one is way too old. It's no longer visible there anymore. Okay, probably I deleted it a long time ago. But of course, these are metrics. And these, by the way, can be added into a dashboard. So you can add this graph into a dashboard. And if you don't have a dashboard, you can just maybe create one and then play the dashboard into a particular screen or TV so that you are able to gain real-time insights into what your applications are doing based on metrics or even logs as well. There's so much you can do within CloudWatch. I urge you to just browse through. You don't have to understand a lot, but just a high level of what CloudWatch actually does for you. Moving right along, let's talk about load balancing. If you only have one EC2 instance, your client will connect to that one EC2 instance. Not a problem. But what happens when you add more EC2 instances because one EC2 instance is not copying? Your clients do not know other instances. It will be a problem to even let them know, because what happens if those instances are deleted and they're added again, so on and so forth. Which is why we need a load balancer. A load balancer will distribute the load in a balanced way across all of the instances that you have. So technically, all instances, they will get their share of dealing with the traffic. And this is done in a round-robin fashion. Round-robin means we send to the first instance, it responds. We send to the second instance, it responds. We send to the third instance, it responds. And then we start again from scratch. So that is round-robin. It's how load balancers work by default. The good thing about load balancers is that they are a central point of contact into your application. Nobody gets in there from any other way other than going through a load balancer, which means in terms of security, you have a single entry to your application. If you want to secure it, that's a place that you need to worry about a lot. But let's talk about that as we continue. What are the benefits of elastic load balancers? Elastic load balancers, they are highly available and elastic themselves, but they bring that capability into your application as well as you configure it, because now, which means when you send the traffic through the load balancer, it will go across to multiple instances at the back end, as you saw in the previous slide. So now, what happens if one instance is broken or one VM is broken? It does what is called a health checks by default on your EC2 instances. So it will never send traffic on a broken EC2 instance. It only sends traffic to the live instances. You can secure your application by including TLS or transport layer security, or sometimes called SSL, secure sockets layer. This is the way of configuring HTTPS for your application. so that the traffic is encrypted in transit. Especially if you're doing banking or critical applications, you want to make sure that you are transacting within a secure line. It has many other features, like for example, sticky sessions, where if you are connecting to a particular EC2 instance from a particular client, you want that instance to continuously serve that customer until the session is stopped or is no longer there. So sticky sessions is just one of the nice features of load balancers, and many others, of course. It does emit logs and metrics as well, so that you are able to send it into a central place and understand the traffic that is coming through. You can, of course, make your application globally accessible by making the ELB to be a publicly facing type of a load balancer, so that anybody can be able to connect to it. What are the components of load balancers? A load balancer will have a listener. Think of a listener as maybe port 80 type of a listener, or maybe 443. So this is not secure, this is secure. So those are two listeners I have for my load balancer. I can have then a target group. A target group is a collection of resources such as maybe Amazon EC2 instances, AWS Lambda functions, or even IP addresses if those instances are sitting on premises where I don't have access to them directly. So now with the target group, I'm able to say if you are coming through on this listener, I'm sending you to a target group that is made up of maybe EC2 instances. But sometimes I can have many different options to say, if you are coming through and you're looking for /API, I want to send you to a particular group of EC2 instances or target groups. If you are coming with /images, IMG, I'm sending you to another target group. That is where rules come in to define exactly how the path is supposed to be, or any other configurations as part of that load balancer. We have 4 types of load balancers within AWS. We have an application load balancer, which works at layer 7, or sometimes called an HTTP layer. We have a network load balancer, which works at layer number 4. By the way, these layers, they are OSI model. If you come from networking, you might be familiar with that. So layer 4 is the TCP layer. So network load balancer works on the TCP layer. We have a gateway load balancer, which is mainly useful for appliances. So if you have an appliance that you want to connect to, it could be maybe appliance for a firewall or any other type of appliance. You can use a gateway load balancer as a front end to that appliance. And then we have a classic load balancer, which by the way was the first load balancer within AWS. That's why it's called classic. It works on a TCP layer as well, TCP layer 4. It is slowly being replaced by application load balancer and network load balancer in terms of many of the functionalities it has. And we recommend customers to slowly also move away from it, unless it's really critical that you stick with the classic load balancer. So the last one to cover is scaling. I've spoken a lot about being able to add more instances or scale, so on and so forth, but what does scaling actually even mean? Scaling comes in 2 fashions. We have vertical scaling and horizontal scaling. Vertical scaling is also called scaling up and down. Horizontal scaling is also called scaling out and scaling in. What do those terms even mean? Let's take a step back. Let's say I am running a very small EC2 instance called a T2 micro instance. And now I'm getting lots and lots of traffic into my EC2 instance that it is now overwhelmed. It can't cope anymore. And if my application is only designed to run on a single EC2 instance, the only option I have is to vertically scale this particular instance of mine. Vertical scaling means I'm going to change the capacity, the CPU, memory, or even disk, and make it bigger. From T2 micro, it's now a T2 medium. I continue to serve traffic, and if it's small again, I then go on and create an even a bigger one. That's called vertical scaling or scaling up. If I don't no longer require so much capacity, I can surely scale back down. They're scaling down so that I minimize, of course, the cost and the capacity for my EC2 instances. Horizontal scaling on the other side doesn't change the size of the instance. Instead, it adds more instances that are exactly the same size over and over again. Normally, this happens if your application can run in many instances at the same time. And you tend to see this also when you have a load balancer as well, where traffic can be sent on one instance. If this instance is no longer coping, you add another one, and then you tell the load balancer that now there are two instances. Do the round robin sending of traffic into those instances. And if they're not copying, you add another one and another one. And of course, if you no longer need those instances, you can go ahead and also delete them as well to say now I no longer need until I'm back at the minimum as well. So this setup of changing the instance, especially on the horizontal side, it requires auto scaling to be done efficiently. So what exactly is Amazon EC2 auto scaling? EC2 auto scaling helps you as a customer to increase the application availability and lower your cost, especially when you are scaling back in, by adding instances and removing them whenever you want to. By doing this, you're going to be increasing the fault tolerance and high availability of your application, and thereby lowering cost, especially when you scale back in. For Amazon EC2 auto scaling to be able to launch new EC2 instances, it needs to be told, especially on what type of an EC2 instance it needs to launch. How do you then tell it? You tell the Amazon EC2 using the launch template. The launch template is a way of defining what instance are you going to launch in terms of the instance type, the Amazon machine image you are going to utilize, what subnet is that instance supposed to be launched in, if it's going to have an SSH pair, so on and so forth. What's even nice about the launch template is that you can have different versions. Maybe that was version 1. On version 2 of the launch template, I now have a security group that is attached on my EC2 instances as they are being launched. Oh, maybe I made a mistake on the security group, or perhaps I'm adding another port to be allowed. I create another version of the launch template. I now change the security group, so on and so forth, including, of course, changing the instance size and even the AMI as well. That is on the new version. I can then take this launch template and then supply it to the Amazon EC2 auto scaling group so that when it launches new instances, it's going to be based on exactly what I want via the launch template. Here's an example here of an Amazon EC2 auto scaling group. When you create it, you specify the minimum number of instances that must be there all the time, even if it scales back in by deleting the instances. How many, in terms of the minimum, should I have all the time? You can also have the maximum as well, which must be configured to say if I ever scale out to add lots of instances, how many will be the maximum? That is the maximum configuration and the minimum there. You can set the desired count, desired capacity to specify how many do you actually require right now when you create the auto scaling group. That is called the desired count. Like in this case, we only require about 3 of them as we create this auto scaling group. Of course, we can expand it to 5 or can get to a minimum of 2. How exactly do we then change this desired count? Because if it's not going to change, then what's the point of it? Well, there are some ways to change it, and that is called scaling policies. Scaling policies are what you configure for your Amazon EC2 auto scaling group to change the capacity of your EC2 instances that are provisioned. We have a simple scaling policy, which means that when there is a requirement, we are going to add one EC2 instance. Let's say the CPU is very high. We now need to add an instance. We're only going to add one instance if the CPU is high. We're going to wait for the cooldown period, which by default is about 5 minutes. And then if the CPU is still high, we're going to add another EC2 instance. But of course, this might not be good enough, especially if, let's say, this is your CPU utilization and this is the amount of time. And all of a sudden you have a sale from one CPU utilization to 100%. The traffic comes in and then boom, it goes to like 100%. Adding one instance and then waiting 5 minutes to then add another one if then both of them are overly utilized is not going to be good enough for customers. That is why we have step scaling. Step scaling policy, it means that we increase or decrease the group of instances. We specify that if we are at 75%, by the way, I meant 100 here. If we are at 75%, we must add 2 instances at the same time. We're not going to check how many were there. We're just going to add 2 instances if we are at 75. But if we reach 100% utilization, we're just going to add 5 instances at the same time. When we do this, we immediately accommodate all of the load coming through at the same time because of that step scaling. Right? But of course, both of these require you to check the CPU as it grows and know that when it's 75 or maybe 90 or 100, what am I doing? We have target tracking scaling policy. So how does that one work? This works in this manner. We set the target of 75% CPU utilization for my auto scaling group. So if there's more traffic coming through into my EC2 instance, guess what's going to happen? The CPU is going to start to skyrocket. The moment the CPU goes to 80, because we are tracking the target and we want the CPU to always remain at 75, what are we going to do? We're going to add an EC2 instance. Once you have more EC2 instances, it's now going to lower the CPU back to like close to 75. If we get bombarded by traffic to a point where we have maybe 90% CPU utilization, we're going to add instances so that we can push the CPU utilization to 75% because we are tracking the target of 75%. Those are some of the ways you can actually configure the scaling. But of course, within these policies, there are some configurations that you can actually do, especially on your site. When we talk of features of auto scaling groups as a whole, it's really about bringing that automatic addition or subtraction of your instances in your architecture in an automated way without you lifting a finger. If you don't want an automated one, you can also configure scheduled scaling, which means it's still a scaling, but this one is user defined. You will normally do this if maybe, let's say, you have developers that are coming through at 8 a.m. in the morning and they are leaving exactly at 5 p.m. in the afternoon. So what I can do is, because I know that I need the VMs for developers at 8 a.m., I can say go and configure this scaling, which means that every day at maybe 7:45 a.m. this is going to trigger scaling because it is user defined, and then add the instances I want. And also at maybe 7:15 p.m. after everybody has left is then going to start shutting down instances because it is user defined. Too bad for employees that want to stay longer in the office, which is not a good thing. Instances will be shut down, sorry, because I have a scheduled, user defined way of decreasing those instances. Auto scaling is useful for managing your fleet of instances, especially when instances become unhealthy. There is an automated health check for the EC2 VM itself, and you can also include an ELB health check to say, also check if the application is accessible on this instance. If it's no longer accessible, delete the instance and launch a new one immediately. So in that way, you are managing your fleet of instances. Enough about setting up scheduling and using policies or CPU and all of that thing. All of that requires effort. There is another scaling capability that uses machine learning. So this one, it tracks how we are using EC2 instances, even if you are launching them manually, especially in the particular auto scaling group, and you want something done. It looks at you, what you're doing, and then it starts to predict what you might want tomorrow, right? Machine learning and AI is very big nowadays. So auto scaling can also use that feature to be able to predict what you might actually need in the future, so that it scales on time before you even think you need it. Okay. Within auto scaling group, I didn't mention this. You can actually add multiple types of instances, like instance types or purchasing options, so on and so forth. For example, you can add spot instances. You can add savings plans. You can add reserved instances, so that you take advantage of those pricing models of different instances, thereby saving cost.